equals 2x before. That was last day. What you didn't know is that logs and exponentials are inverses of each other. You need a log to find an exponential, you need an exponential to find a log, if I ask you for the inverses. And that's why they're taught together, because if you're trying to find the exponent x, and it's not, you can't accommodate, you have to convert to a log, right? You have to log with the x beside it, or x in the base, you have to convert to exponential, so that's exponential. Go to the podcast. It's down the ground, maybe not be sure this. Oh. I know. Okay. So. Oh, I don't even match your socks, guys, but they're the same brand. Pink? Blue. Okay. So. They don't even know what I'm talking about right now. No. It's going to be a great podcast. Okay, so. If we want to find the inverse of it, when I say inverse, we always say swap the x and y and swap the y, right? So we're going to go x equals 2 to the y. Then, that's lovely, but when you find the inverse of the equation, remember you can swap the x and y, so then you have to get it to y equals, that's the next step. So, our y is actually the exponent. So the only way we're going to get into y equals is actually by converting it to a log. So the base of my exponent becomes the base of my log. Let's if it doesn't stay with it, so the side is now going to be x, and it's going to equal 1. Okay? These should reflect on the identity line. They should reflect on the y equals x line, because the x's are from the y's and the y's are from the x's, right? So let's look. So y equals 2 to the power of x, and then y equals log 2 of x. And then I'm going to put in the line y equals x, because that's the identity line, and they should reflect on it. I just picked the pink one instead of the black one. It's totally beauty color, because I think it's even more noticeable. So blue is going to be your exponential, red is going to be your log, and they should reflect on the pink one. So that's your identity line. They should reflect on that y equals x line, because that's the line that's 1, 1, 2, 2, 3, 3, 4, 4, 0, 0, 1, 1. That's where your very exponents will last be, because that's them. That's the same. So these do, they reflect. This red graph technically keeps going, but it's taking you out. Let me draw. Anyway, it keeps going down here, just like this. Because you calculated stupid. Don't fall for that. It'll check and look like it stops. But if you actually look for like y equals -10, it's still there. So a lot of people will tell you that the range is not y you are. They'll say it's greater than or equal to -3. For example, on this one, greater than it. When it's not, the graph actually keeps going. It just looks like it does. So don't let a lot of you. Okay? All right. So we have that. So we know the domain of the exponential, it looks like this, correct? We went over this last day. I have a horizontal asymptote. At y equals 0. What's the only thing that lives in my horizontal asymptote? What's the only translation that needs it? Vertical translation, and what's the only thing that changes my range? A reflection in the x-axis, right? Because it would cause it to be down. Those are the only things that will affect my range. That was from last day. So, my domain of an exponential, unless it's a word problem, is XCR. Because it goes out forever to the left and it goes up forever to the right. Or an interval notation making things be positive. Now, my log graph looks like this. So the domain is XCR. Because it's an inverse of it, the range is going to be YR. Remember your X and Y is just split. So the range of this graph over here is YR. Right? The range of my exponential of this 2dx graph is going to be greater than 0 because I have no vertical translation, right? And I have no reflection. So it's going to be y is greater than 0. I can have a whole bunch of, I can have other things added to this. I could have like x plus 3. I could have 2 bracket x plus 3. And it's just going to shift it over and make it wider. But it's not going to change my range, right? So my range is going to be y such that y is greater than 0. Y, or in interval notation, 0 to infinity. Now, my range of my original will be my domain of my inverse. So your x and y is just split, right? So if they gave me an exponential function and asked me for all the information from the inverse, I could literally just find it off the exponential and flip it, right? If they gave me a log graph and they asked me for the anything off of its inverse, which would now be an exponential, I just find all the stuff for the log graph and flip it, right? So the only time you actually have to find the equation of the inverse is if they say determine the equation of the inverse. Other than that, you can look at the original graph and flip it. Because I'm not even looking at the log graph right now, I'm just finding stuff off this exponential. So the domain is x such that x is greater than 0. And interval notation is awesome because nothing changes. You literally just rewrite it for the same range beside it. This one has a horizontal asymptote. And you can't say 0. That's not an asymptote. That's just a value. It's 0. You have to give it an equation. So the horizontal asymptote, it's on the x-axis. The x-axis is actually the equation y equals 0. So the exponential has a horizontal asymptote at y equals 0, where the log is going to have a vertical asymptote at x equals 0. Right? What are the x-intercepts of my exponential? Good question. What are the x-intercepts of my exponential? The block graph. None. The asymptote's on, right? So this one has no x-intercepts. So what would my inverse, the log function, have? No y-intercept. And then the y-intercept of the exponential, if I want to find the y-intercept, I know it's y equals 2dx. And if I'm looking for y-intercept, I said x equals 0, right? So I'm going to go y equals 2 to 0, which is just 1. So I have a y-intercept of 0 and 1, which means what for the inverse? So the next intercept at 1, 0. So determine the inverse of y equals 3 to the x plus 1 minus 4. So if I want to determine the equation of that, I actually have to determine it, right? If I ask for the domain, range, x-intercept, y-intercept, asymptotes, anything of the inverse of this, I wouldn't actually have to find the equation, right? I could just find everything off of this one and then flip it. Okay, so we're going to find the inverse of this first. So to find the inverse, we're going to go x equals 3 to the y plus 1 minus 4. And in the end, I need to get it into y equals. So what's the first thing I'm going to have to move? -4. And then I'm going to have to move the 3, because I can't convert to log until I actually have 3 pieces. If I have more than 3 pieces, I need to do some math first. Okay? So I'm going to add 4. going to go x plus 4 equals 3 to the y plus 1. And then what am I going to do? Divide by 3. So I have x plus 4. Now what I can do is I can divide this by 3, or I can put in front of the bracket a third. It's the same thing. And for actual transformations, it's better to have the third outside, right? Because then it would be a horizontal stretch by 3. And now I have 3 pieces. This is one piece on the left, this whole thing, one goes this, and 2 to the exponent. Now I can convert it to a log. So now I'm going to get log base exponent plus base or log 2. What goes beside it? What's over here? So 1/3 x plus 4 equals y plus 1. And then what am I going to have to do? Subtract the log base 2, 1/3 x plus 4. Yeah? Now I can see any transformation. So the base of 2 is like the base of the exponential. The base just stays the same, right? So that doesn't give you transformation. What's in front of here is my vertical stretch or reflection, so I don't have, right? What's back here is my vertical translation. What's in the bracket is my horizontal stretch, reflection, and translation. So this 2 down here in this base doesn't affect it. It just gives you a base function of log 2x. And then you're just shifting the base function log 2x by all these different transformations. So this just stays the same. This just stays the same. And it's based on the log base 2 of x function. And if I took that log base 2 of x function and I applied all the red things, I would get my new graph. Right? Okay. So of this log base function, log graphs have vertical asymptotes. So exponential graphs have horizontal asymptotes. Do you agree? So the only thing that was the horizontal asymptote was the vertical translation up or down. And the only thing that changed the range from being greater was a reflection in the x. It made it less, right? So logs are this way. Logs are horizontal. So now I have a vertical asymptote for a log, and it's at x equals 0. It's on the y-axis. So what's the only thing that's going to move my vertical asymptote? A horizontal translation. Does the horizontal stretch do anything? Make it wider or narrower? No, it's an invisible line. You can't make it a fat or invisible. So that moves it left or right. And then normally my domain would be greater than 0. What could cause it to be less than the asymptote? What will cause it to be less? A reflection in the y. A reflection in the y. Okay? So this one has a the other one is horizontal. This one has a vertical asymptote. What's it at? Your vertical asymptote is normally on the y-axis. It's normally at x equals 0. Correct? So only a horizontal shift would change it. What's my horizontal translation? 4 to the left. So normally, it's here. That's where this base function should be. Correct? And I'm now moving it 4 left. So it's down here, right? And that base function would normally have a graph that looks like this. Now that graph just been completely shifted over here, right? That's all that's happening. Is there a reflection in the x-axis? Or, sorry, reflection in the y-axis? No, so my domain is still going to be greater. It's not going to be less. So my vertical asymptote is going to be at x equals -4. And my domain is going to be x such that x is greater than -4. Because there's no reflection in the y-axis, right? What are my translations between the log base 2 of x function and this one? My transformation. I have a horizontal, remember we have two stretches, reflections, translations. It has to be in that order. Search stretches, reflections, translations. You can't write in whatever order you feel you like. Okay? Stretches first. The only stretch I have is a horizontal stretch. Horizontal stretch by a factor of factor of 3 about the of the y-axis. Do I have any reflections? No, I don't have a negative in front of the word log, and I don't have a negative in front of the x. So no reflection. Then I have a vertical translation. One down. It doesn't affect my range because my range is YR. Right? Vertical translation one down? Nope. And then a horizontal translation. So we could write a little note to ourselves. We could say that the vertical asymptote for logs is always x equals the horizontal translation. Correct? The vertical asymptote is always x equals the horizontal translation. And your range will be y such that y is greater than the horizontal translation. YR. Or y such that y is less than the horizontal translation. YR. What's the difference? How do we know it's greater? It's to the right. If it's to the right, it's greater, which means there's no reflection in that, which exponential theorem, in the y-axis. So it's going to be greater if there's no reflection in the y-axis. So it'll all be on the right, right? Okay. And then if there's a reflection in the y-axis, it'll all be on the left. It'll be left. So if I give you y equals -3 log, say y equals log base 4 of x becomes y equals -3 log base 4 -1/2 x minus 3. Okay, so y equals, the base is the same, right? Same thing with exponential. These bases are the same. They don't change anything, right? They do have to be the same though. So I want you to state the transformation. That's the first thing, state the transformation. The second thing I want you to do, mapping. Third thing, domain. Fourth thing, range. Then I want asymptote. And I want x-intercept. y. You absolutely have to take the negative half out. If you don't do that, the horizontal transition, yeah, take the negative half out. Got it. There it is. There it is. This is negative a half x plus 6. Remember, it changes the sign and it doubles it. You divide by half and multiply. So vertical stretch by a factor of 3 about the x-axis. Horizontal stretch by a factor of 2 about the y-axis. Reflection in both axes. Reflection in the x and the y-axis. Vertical translation line up, horizontal translation and the mapping for the xy becomes, you have to have that part of the mapping, right? So the point becomes x is multiplied by negative 2, and then I subtract 6. And my y is multiplied by negative 3, and I add. Because words and mapping are the same, right? It's a log graph, so your domain is either going to be greater than something or less than something, right? Now, we'll go to asymptote first. So this is going to be a vertical asymptote, which is normally at 0, at x equals 0, but it's been moved 6 to the left, so it's now at negative 6. So vertical asymptote at x equals negative 6. My domain is either going to be greater than negative 6 or x is less than negative 6. I have a reflection in the y-axis, so normally it would be over here. It's now reflected on this side, correct? So my domain is actually going to be x such that x is less than negative 6 because I have a reflection in the y. And then less than negative 6 would be negative infinity, negative. My range is y yard. It doesn't even matter what my log graphs on a sewer problem will be y yard. And then you can deposit infinity. Now x-intercepts, I have to put 0 into y. So I'm going to go 0 equals negative 3 log 4 negative a half x minus 3 plus 1. I have to isolate x. I don't know what's beside x. If I don't know what's beside the log, if I don't know what's beside the log, I'm going to have to convert to exponential. But I can't convert to exponential until I have 3 pieces, right? Yeah. If you take it out or leave it in the center. Yeah. I just wanted to use the original so I didn't possibly make a mistake with it. But you can totally have it happen. So I'm going to subtract 1 first. So I'm going to get negative 1 equals negative 3 log 4 negative a half x minus 3. And I still don't have 3 pieces. I now have 4 pieces. I have 5, I now have 4. So I need to divide that negative 3 over. I'm going to divide. So I'm going to divide by the negative 3. And so I get a third equals log base 4. And you could technically find this using your calculator, but if they say algebraically, you're in trouble. Right? Now I have 3 pieces. Now I can convert to exponential. So whenever I'm finding x-intercepts of logs, I'm going to convert it to exponential. And when I'm trying to find x-intercepts of exponential, I'm going to end up converting to log. Because you're going to have to bring this in. So, my base my log is 4. It doesn't stay with it. We're friends with it, so it goes to 1/3. And it equals negative a half x minus 3. And then I just need to isolate x. I'm going to add 3. So 4 to the 1/3 plus 3 equals negative a half x. And to get rid of negative a half, I just multiply by negative 3. So x equals x equals negative 2, negative 2, bracket 4 to the power of alpha y equals n, so I'll give you the fraction, 1/3 plus 3. So I like making it look exactly the same. What's my problem? It says go to, I took me to it, I have an extra bracket, right? Whenever there's a go to, push it, it'll often go to your issue, and get rid of it. I said go to, because like go to is like number 1, like here is like number 2, just pick the go to. Yeah. Just take the, you have to go alpha y equals enter before you. So you're going to go 4, and oh sorry, you're going to go 4 and then alpha y equals makes you use the 4. Arrow over, you're on the 4. So go 4 and then arrow over. Yeah. Okay, that will run. A negative 9.17. So we could have gotten that from our calculator for sure, but if this algebraically, we got enough, right? And then our y-intercept is way easier. Finding our y-intercept is always easier. You just put 0 for x. X-intercepts are the hard ones to find for you. Next, convert to a log, convert to an exponential. Y-intercept, you just plug in 0. So my equation is negative 3 log 4 negative a half 0 minus 3 plus 1. So you're literally just plugging that in. And the negative a half times 0 is 0. It's going to be something else. Okay, plug it in. I'm going to go negative 3 math, log base, 4, negative 3 plus 1. And I know I'm going to have an error. What times I have this on the log? A negative number. What times I have in the base? A negative number. So if this 4 was negative or beside a log's negative, it's going to be not at me. Okay, let's look at it. Why would it be mad at me? What is my domain? My domain is x is less than negative 6. So I have a graph that looks something like that. How many y-intercepts does it have? None. It literally doesn't cross it. So when we're going to do this, this is going to be a non-real answer because there are no y-intercepts. And they could ask you to explain why there's no y-intercepts. And you could explain that great because when you plug in an x for 0, you get a negative beside a log, which is not possible, right? And you could also say, because the domain is less than negative 6, the graph is completely to the left of negative 6, therefore it will never cross the line. So you can explain it, and they will probably ask you to explain it. Okay, your homework. Page 9 of the book, like,